how to perform one-way ANOVA in SPSS. What you need to know is just in ANOVA, we compare mean of more than 2 samples or more than multiple samples. But in this video, we restrict ourselves in comparing mean of only 3 samples. I'm comparing the level of education and the distance which an individual can through a javelin if there is significant difference. What we need to do to perform one-way ANOVA is just click the option Analyze, then move to where we have Compare Mean. After moving to where we have Compare Mean, we move to where we have One-Way ANOVA, and we click the option. So let me remove this option. I had put them later so that I can explain to you what we are doing. So when you open it, you get your data like this. So our dependent variable in this data set is the distance which the individual can throw the javelin. That one is the dependent variable, but the factor variable is like similar as independent variable. Our independent variable is the level of education of the players. So we put it as the factor, that is the factor determinant. From there, we will come to where we have construct. No, we come to where we have post hoc. And in one-way ANOVA, in SPSS, we usually assume the equal variance by Turkey. You just select Turkey and then click continue and then click OK. So the task has been done for us by SPSS. So what we need to do in order to arrive to a conclusion, the one important thing I can advise you to first look is this significance, which is here. I don't know if using the cursor you can see it. You see that we have 0.301 significance that the mean are the same. So this means we have 30.1% chance that the mean of this sample of these groups who are throwing the javelin were the same. So this 30% is above the 5% confidence level. The 5%, the 95 is above the above the 5% or 0.05 confidence level which we are using. We are using a 95 confidence level interval. Thus, why am I missing out? So there is 30% chance that the mean are the same based with the fact that we adapt a 95% level, the confidence level. So this means that if we have 30% probability or significance that the mean, 30% chance that the means are the same, so that one is above the 5%, which we take as our standard interval, which we can make conclusion with. So this one 30% is above it. So that one means that we should reject, we should adapt another hypothesis that the means of the distance which this individual can throw the javelin is relatively the same. Even comparing these means and comparing the number of students, since it seems that there are many outliers, you can notice that the mean have no significant difference. You can come here again and look to the upper bound and lower bound. If there exists a 0 between the upper bound and the lower bound here, I don't know if it is clear where I'm moving the cursor. If in lower bound and the upper bound there exists a 0 between, can you notice here in our data set there exists a 0 between these board? If there exists a 0, you should adapt another hypothesis. If between the upper boundary and lower boundary there exists a 0, you accept the null hypothesis and reject an alternative hypothesis, since the mean are relatively the same. But the important thing which I can advise you to look at is this significance. Significance talk more in ANOVA. If significance is above the 5%, 5% is above 5%, you automatically adopt a null hypothesis. Thank you for watching. I was a bit confused. I have said wrong without interacting with this thing. So I think I have driven the point home. Thank you for watching. Kindly don't forget to give the video a thumb up so that you never miss out any of my future content like this. Also, don't forget to give it a subscription. Thank you for watching.